So every line is worth 3. We don't have to label it. It gets messy if you put the number for all the lines. Just put the numbers for the benchmark lines. These are called benchmark lines, okay? All right. Now that I got the graph all set up, all I need to do now is plot the dots here. So, starting with 54.88. At 70 centimeters, the speed was 54.88. Here's 45. I'm going to count up by 3. 48. 51. 54. My number was 54.88, so it's almost 55. 55 would be about the third of the way higher. Because this here is 57. Okay? And so in between here and here, we have 55, 56, and 57. And 50, that's going to be closer to 55 than 54. So I'm going to mark right here. All right? That's where 55 is. And that's on 70. I don't have lines here like you had on your graph paper. So what I'm going to do is I'm going to draw a little imaginary line so I can help myself put the dot in the right place. Goes about right here. All right. So there's my first dot. Let me erase those marks here. All right. Next one. We're at 50. So let me draw a line from 50 up. All right. Yes, yours is going to be different because your numbers are different from mine. I have a different ramp. Remember, my ramp setup is a little bit different from yours. And yes, I have great hearing. Told you my hearing is very sensitive. All right. All right, so at 50 centimeters, it was 50.25. So I got to find that on here. Here's 45, 48, 51. 50 is 2/3 past 48, 1/3 less than 51. So I'm going to go across here. And when I'm saying 1/3, guys, it's because in between each one of these lines are whole numbers. So this is 48, right here is 49, right here is 50, and then of course this bigger line is 51. All right? There are 3 imaginary spaces between there, equally distributed, and each one is 1. Okay? That's what I'm saying, 1/3 across, 2/3 across, and whatnot. All right? So there's my next dot. Let me erase my imaginary line here. All right. The next one was 30 centimeters. So let me draw my imaginary line straight up here. All right. And then it was at 42. Here's 30. Here's 45. Minus 3 is 42. So it's exactly right there at that marker. That's right at eye level. So that helps. All right. All right. Now, the last one is 10 centimeters. Let me draw my line here. All right. And that's 27. Again, that's a multiple of 3. That's right here. 30 minus 3 is 27 right here. You draw my line going across. All right, now I've graphed the dots. I've plotted our speeds on the graph. I've plotted our speeds on the graph. That's what plotting is. And it says plot is the speeds on a graph, or plot anything on a graph. You're putting dots where those things are located on the graph. Okay. So there we go. Now, it asks you to plot your data. Okay, we did that. It says draw a line through the points. The line should show the pattern of the points. Do not connect the data points dot to dot. If you connect the dots with straight lines, going from here to here, then here to here, and here to here, you're not going to show a pattern. You need a curved line that goes through them all. It goes through the majority. Here, it would be perfect if I didn't hand do this and I had graph grid up here. You would see a perfect curve. Last class I got lucky and I had it perfect. I eyeballed it just perfect and had a perfect curve. Here, this is a little off right here. Okay? But the curve looks like this. We should go right through all the dots. This happened in the first class too. I was off a little bit here. This dot should have been right here. Let's pretend it was just for our sake. Okay? Alright, because if I go over here, it's not perfect. I did it, I eyeballed it all. Okay? Alright, so anyways, you should have a curved line like that. Okay? It's not a bunch of straight lines connecting dots, it's curved. Now the reason why it needs to be curved is because if it's not curved, we can't figure out exactly what the speeds are here. Let's say I want to know what the speed is at 40 centimeters. Okay? If this was a straight line, it wouldn't be in exactly the right spot. It would be too low. Okay? Alright, so we need that curve to show the pattern, not connecting the dots. Connecting dots doesn't show the pattern. Alright? Now that we have that information, it asks you to convert them from centimeters to meters. Real easy, guys. Real easy. All you need to do is remember, it says in there too, it gives you the clue that there's 100 centimeters in every meter. If you want to change the meters, you divide by 100. Okay? Because meters are bigger than centimeters, which means there's less of them. That means the number has to get smaller. And since 100 goes into it, you know you're dividing by 100 to make it smaller. And when you divide by 100, all you do is move the decimal point over to the left 2 spaces, because 100 has 2 zeros in it. Okay? So here, when it asks you to change the wing length to meters on that last table, it has you put the answer here in meters next to this one. You just take the 5. The decimal's here. This is the whole number, so the decimal is right to the right of it. You move it 2 spaces. 1, 2, 0.05. So when we convert centimeters to meters, the wing length of the car is 0.05 centimeters, or 5/100ths of a centimeter. I mean meters. Alright, change it to meters, sorry. It's 5/100ths of a meter. Alright, now, once you have that, you can, you're supposed to put in the average times in that table. For that, you didn't have to redo the trials, you just copied the average times from this table into the next one. Okay? Now, once you have that, you can take 0.05 and divide by these instead of 5 divided by these, but you don't need to do all that. Again, all you have to do is move the decimal point over 2 spaces. So, to convert this to meters, you just move it over 2 spaces. We have 0.5488. This would be 0.5025. This would be 0.4215. This would be 0.2712. Okay? And then it would be meters per second instead of centimeters per second. All you do is move the decimal point over 2 spaces. That's it. Alright? That being said, let's get back to the graph. Alright. Now, we want to know if we can figure out the speed of the car at any given point on that graph, just from looking at it, without having to test it. Okay? So here we go. Oh, I skipped a question here, didn't I? Alright, so, but that's later on. One question I skipped was the conclusion, guys. Now we just did all the data collection, came up with the graph, came up with the table. The conclusion, and that was the data collection part. Now the conclusion is what? We looked at the numbers here. Remember we said at the top of our hypothesis was that at the top of the ramp, the bottom of the ramp is moving about twice as fast as it is at the top of the ramp. Well guys, is 54.88 about 2 times faster than 27.12?
A little. No. Wait, maybe.
Yes, it is. 27 times 2 is 54. Right?
Yeah.
Look, let's divide it. 54.88 divided by 27.12 equals 2.02.
That's close enough.
2.02. So it's 2.02 times faster than at the top than, I mean at the bottom than it is at the top. So yeah, it's about 2 times faster. So your hypothesis was correct because the speed did turn out to be about twice as fast at the bottom as it is at the top. So when you answer a conclusion, you don't just say yes, your hypothesis is correct. You have to explain how you know it's correct, which I just did. Okay? All right. Now, and that was 6A. So that was on your paper, it was 6A. We didn't do 6B because the groups are all finished at different times. All right. I already went over the table on 7.1. I already did that. Now we're at 7.2. All right, here we go. It says you can use a graph to make a prediction. Use a graph to predict the speed of the car at 40 centimeters. This will be the place on the x-axis of the graph between position number 1 and position number 2. All right, so 40 centimeters. You should have been able to tell about how much the speed is of the car at 40 centimeters by looking at the graph. I mean, draw my imaginary line like you have with your graph paper. Alright, so it's right there. Now we gotta go all the way across and see where it matches up over here. Alright, it's about 48. Maybe a little higher. So it's somewhere between 48 and 49 probably. That's my estimation. Okay. Now, to see if my estimate's correct, we need to do it. We're at 40 centimeters. I'm going to put photo gate at 40 centimeters. And remember, that graph is not accurate because I did it by hand, eyeballing. I don't have graph paper. I didn't use rulers. So it might be a little off, but maybe I'm going to get lucky and it's perfect this time. We'll see. One time it was perfect. But it's going to be close enough that you can say, yes, you can use a graph to figure it out without having to test every single position on the photo, on the ramp. So 1062, I'm going to write that here, 1062. All right, let me get another time. Remember, we want the average. 1075. Do it again. Yeah, exactly. All right. Go. 1083. All right, I'm going to get the average. 0.1062 plus 0.1075 plus 0.03. I didn't take the shortcut. 5 by 3. 0.1073. That's the average. All right. The average is 0.1073, so I'm going to do 5 divided by that. 5 divided by... Guys, what's going on back there? My eyes are definitely on the calculator. Doesn't mean my ears aren't towards you guys. I can do you. Equals 46.59. Yeah, so again, being hand-drawn is made more difficult. Yours should not be so far off because you had graph paper. So it's much easier for you. But 46, it's not so bad. Okay? 46.59, not so bad. That's about a 1.5 centimeters per second difference. Alright? But yeah, you should be able to see what the time is here without needing to do the test. Without having to do it, you should be able to tell what it is.